Hello my dear students. As we discussed in the previous video, we discussed about conservation of momentum, in which we discussed about what for the one isolated system that means what? There is no external force. So that system which is known as a external isolated system. So in which we understand the basic concept of the conservation of momentum. So momentum के बारे में हमने what we discussed in that video, we discussed about the final momentum of the system is equal to initial momentum of the system. Okay, so this is all about the previous video. So now in this video we are going to discuss about the equilibrium of the particle. So one particle which are into the equilibrium, that means what? That will be at a stable condition. So that is considered as the equilibrium of the particle. So now which concept we have to study over here? Let's consider that. What do we find equilibrium? So when the net external force on the particle is 0. So this positions, that conditions which is known as a equilibrium of the particle. What? When the net external force on the system of the particle which is 0, then that is considered as an equilibrium of the particle. So now consider that, for example, if two forces, one force which is we can name as a F1 and another force which is equal to F2, act on a one particle. Okay, two forces, one is F1, another one is F2, which are act on one particle. So what are the conditions for the equilibrium? Equilibrium की conditions क्या होगी? As we know that force के बारे में considerations करना है तो F1 is equal to minus F2. Okay, so we can write in this form also. So let's see. This is in terms of the figure. This is our F1. Like this is our F1. But according to our rules, according to the rules of Newton's law of motions, both have equal magnitude but the opposite. So over here, F1 which is in this direction, F2 which is also having same magnitude but which are in the opposite direction. So we can write like this one. And the net sum will be 0. So this equation also we can write F1 plus F2 is equal to the 0. Okay, so these conditions which is considered as an equilibrium condition for the particle. Okay, so the two forces on particle must be equal and opposite. Okay, so we have to remember this statement using this figure. One is over here F1 and another one which is the F2. Okay, both are the equal and opposite. Now consider that one system, one particles which is having three types of forces, and that we have to consider. So consider that under the equilibrium conditions, the three concurrent forces. Now what about the concurrent? Concurrent, that means these all forces are at a one time. Okay, so at the same time we can say, so that forces this is known as a concurrent forces. That means what? हमारा three we are considering over here F1, F2 and F3. Three forces are acting on a one particle at the same time. So and we have to find out the resultant. The resultant we have to use using the vector sum of these three forces. Okay, so equilibrium we have to find out for that we have to find out using what? The vector sum of the three forces will be 0. So we can write F1 plus F2 plus F3 is equal to 0. So these three concurrent forces is equal to the 0, and these are the vector sum of the three forces. Okay, now consider that figure. Figure में क्या दिया हुआ है? The equilibrium under the concurrent forces. So as we know that one which is considered as the F1. So this is our F1. Another one force which is F2 which is showing over here. And third one which is our F3 which is showing like over here. Now to find out the resultant. Okay, so let's consider to find out the resultant. We are using which principle? Vector principle, using the parallelogram principle for the vector summations. We have to consider over here the magnitude of the F2, which is projected over here. So which is shown as a dotted line F2. And another one is the F1, which are the projected over here, which is equal to F1. So the resultant of F1 and F2, which is shown over here. So this is our resultant. So the system which is in terms of the equilibrium, कब वो equilibrium में होगा? ये जो force है, which is equal to the F2. Then and then this particle will be, we can consider as a equilibrium positions. Okay, so over here we can write using the simple triangle. So what will happen over here? This is our F2. So F2 which is projected over here. This is our F1. So F1 which are projected over here. And the resultant, as we know that क्या आएगा हमारा, which are the summation of F1 plus F2 is equal to the क्या आएगा F3, which is into the this direction. So that's why that will be the this direction. The arrow will be like this one. Okay. Now, suppose we have to write some x, y, and z component of the particle. So using this equation, F1 plus F2 plus F3 is equal to 0. Now we have to write for the x, y as well as z component. For that, what we can write? F1x plus F2x plus F3x is equal to 0. What we are considering? This is the equation for the x directions. We have three forces which is for the x direction. So that time this equation will become. Now for the y direction, so y के लिए क्या होगा? F1y plus F2y plus F3y is equal to 0. And third, F1z plus F2z plus F3z is equal to 0. So these three equations will become using this general simple concept F1 plus F2 plus F3 is equal to 0. So now F1x, F1y and F1z, there is three components. Okay, so these three components which are considered as what, which are the component of whom, किसके component है ये? F1 के component है. F1 के component है along the x, y, z directions. Okay, so this is the component for whom F1. Now F2 के component क्या रहेंगे? So F2 के component क्या होंगे? F2x, F2y, F2z. So this is the component for the F2 along the x, y, z directions. And what about the F3? So F3 जो है ये हमारा F3, उसके component की बात करें तो F3x, F3y and F3z, which are the F3 along the x, y, z directions. Okay, so this is all the concept about the equilibrium of a particle. So in short हमें mind में क्या रखना है? The total addition, the vector sum of the system when the forces are applied, that will be, we can say as equilibrium. So that time the force, the vector sum, that will be the 0. Then and then we can say as the particle or a system which are in the equilibrium condition.